All right, learning target 2 for systems is to find a solution to a system of linear equations by graphing. And this will be approximating, kind of like estimating, but not really. So let's take a look first at how to kind of do this. So when we're looking at a solution to a system graphically, we want to manipulate equations so that both equations are in the form y equals mx plus b, or find the x and y intercepts by plugging in zeros. You guys know how to do this. We've done this before in our equations unit. And then we're going to graph both lines, and then we're going to find the point where they intersect. So it's pretty straightforward. Let's get to a couple examples. So the first example here, we have two equations, both given in y equals form, so this will be pretty easy. So let's just start by graphing number 1. Number 1 has a y-intercept of 4, so we start at 4, and then a slope of negative 3 over 1. So we go down 3 over 1. Oops, and I misplaced my y-intercept. This is 4. And we go down 3 over 1, down 3 over 1, down 3 over 1. That's what our line is going to look like. So if we graph that here quick, our line looks like that. Our second line here is y equals 6x minus 5. So we start at a negative 5, and our slope is 6 over 1. So we go up 6 over 1. And then I don't think we can go up 6 over 1 anymore, so that's our line there. And you can see that these 2 points intersect at 1, 1. So the solution would be the point 1, 1. If we plug 1 into both of these equations for x, we'll get 1 as the y output. All right, so let's move on to the next one. We'll say this one is our number 1 here. We'll plot it first. Negative 4, or x minus 4, so we start at negative 4. Our slope is 1 over 1x, so up 1 over 1. This is going to be a pretty straightforward line here. So if we graph it, it will look like that. Now our second equation here is given in standard form. So remember, in standard form we can find the x and y intercepts. So if we say y is 0, so y is 0, what's our x-intercept going to be? Well, 3x is going to equal 6, so 1x is going to equal 2. So when y is 0, x equals 2. And then for the other one, when x is 0, 3y is going to equal 6, so 1y is going to equal 2 as well. So we cross there at 0, 2, and it looks like we have that for our line. And you can see again, we have a nice solution point here at 3, negative 1. So our solution is 3, negative 1. X is 3, y is negative 1. So if we put in 3 in for both x's here, we would get negative 1 for both y's, just like we did in learning target 1. All right. So there are a couple special cases that I want to look at when we're graphing. Let's just go ahead and look at these, and then we can talk about why they're special here. If we graph this one, and you might already see it here, we start at negative 2, and our slope is 3 over 1. And so our line will look like this, okay? Actually, that was a terrible line. There we go. Our line will look like this. The next line then starts at 1, there we go, starts at 1 and also has a slope of 3 over 1. So what happens here, and you can kind of see it, is that these lines are parallel. These lines will never intersect because they have the same slope. When two lines have the same slope, it makes them parallel. So when we're talking about a system and a solution to that system, there is no solution to this system because the lines are parallel and they'll never meet. They'll keep on going around forever. Okay? Over here, if we graph number 1, we start at 4. We go down 2 over 1. Another pretty easy line there. And what is actually going to happen here is that once we look at line 2, we're going to find y-intercept. So let's say y is 0, then 4x equals 8, so x equals 2. If x is 0, then 2y equals 8, so y equals 4. So we have x equals 2 and y equals 4 for our intercepts. What's interesting there is that this is what happens. These are the exact same lines. If we took this equation number 2 and we manipulated it into a y equals equation, so 4x plus 2y equals 8, if we took and minus 4x from both sides, then we'd have 2y equals 8 minus 4x. If we divided everything by 2, then we'd have y equals 4 minus 2x, or y equals negative 2x plus 4, which is this line. So here we have infinite solutions because it's the same line. So the entire infinity it goes up and the entire infinity it goes down, all those points will be the same. All right, so why don't you guys try before class to graph both of these lines provided and decide what the solution for the two lines is.